Yeah.
Okay, so this past summer, Ethan spent a week at summer camp. He met several campers that could be described using the following categories below. So we have this thing over here, which is all of the friends from camp, right? All of the friends from camp. So it doesn't matter where you're from, everyone from camp falls into this group. Then we have same city, which I'll highlight in the dark gray, same class in red, same state in blue, same school in green, and different state in yellow. Okay? So, using the graphic organizer, where do you think these things would go? So it said letters. So where do you think, let's do the biggest one. Which of those is the biggest?
State.
Same state and different state. So same state and different state are going to be exclusive of each other. You can't be from the same state and a different state, right? Okay, so I'll write the letters as well. So this would be E, and this would be C. Okay, now what's after state? What's the next smallest?
City.
City, same city. So we'll categorize that with the red, and I'll put the letter as well. Same. Oh, sorry. It's not city. City is not that color, it's the gray.
Yeah, I was confused.
Sorry. And that's A. Okay. Now, what would the next smallest be? Same school? School. So with the green. And we'll say that's what? D. And that only leaves one option left in the middle, B, which is red. Same class. Okay, so we have everything categorized now. Ryan is one of Ethan's camp friends who is in his first period math class. So which groups would Ryan and Ethan belong to in this case?
B.
Okay, so B. And if someone belongs to B, don't they belong to all of those other ones? They also belong to D and A and C and the friends from camp. So not only are they friends from camp, but they're from the same state, they're from the same city, they're from the same school, they're from the same class, and then they're even in the same period. Okay? And we already answered this question, but more specifically, where would we put his name? In which category? B, D, A, C?
B.
We would put his name in B because B is what?
Same class.
Inside of all of the other ones. Please don't whistle. That's a really ugly "the," but this is the word "the." I'll highlight it. That's not a highlighter. That's supposed to be "the," okay? Sorry. So we're going to do this with numbers, okay? We're going to do the same thing with numbers. There's different numbers here. And so we have natural, whole, integers, rational, and irrational. Last year, you guys went over those. So those four should be nothing new. Those four should be something that you've seen before. The only new piece should be the one here at the bottom, and that's irrational. So let's look at this. So natural, the set of positive numbers And they start with what number? Yes, they start with the number 1.
1.
Okay, some examples of this might be 3, 7, 100. What is the only difference between natural numbers and whole numbers? Natural numbers.
Natural number starts with 1, whole number starts with 0.
That's it. They're the exact same thing, except for whole numbers start with 0. So I could give you the exact same examples. So that means 3 in the chart above. If we said that this centerpiece was the B, if this red thing here was natural numbers, you don't have to write this down, but if we said B was natural numbers and we put 3 in there, 3 would also be a whole number, and it would also be the next one and the next one, okay? So that's what we're going to do. We're nesting these things. Integers. What's the difference between integers and whole and natural? They include what? Negative, which is the idea of opposite. Okay? So all of the whole numbers and their opposites. So 1 and negative 1. 1 and negative 1. 3 and negative 3. So numbers and their opposites. Okay? Rational numbers can be written as fractions, and we talked about this yesterday or Thursday. And so they terminate decimals, repeat decimals, and square root of what? Square root of perfect squares. Perfect squares. So let's give some examples. 2 over 7, square root of 121. Okay. Now, all of these things over here all of them are rational. Okay? Everything in the natural numbers, the whole numbers, the integers, they're all rational. They fit inside of rational numbers. And then this group is not. So there's a break here. This group is irrational. It does not fit into any of those. So remember from Thursday, numbers that cannot be written as a fraction. Non-terminating, in other words, they never end. Non-repeating, and square roots of non-perfect squares. So pi, probably the most famous. Okay, square root of 2 is a really famous one as well.
Wait, what is the square root of 2?
Give me 2 numbers that it's between.
1 and 2.
Square root of 1 and square root of 4. So it's got to be somewhere between 1 and 2.
Oh, 1.5?
It could be. I don't know. You tell me.
That's 3.
No. 1.5 times 1.5 is not 3. 2.25 has got to be bigger than 4.
I know, I'm saying that's what 1.5 is.
Oh, I see. Oh, yeah, because it's 15. Yeah, okay. Hi. Okay. So we're going to put these numbers into the category here. And so before we do that, all numbers are real numbers that we're going to talk about. There is some numbers that are outside of this box over here, but we're not going to talk about those right now. And so in the very inside, we have natural numbers. So I'm going to write an N. And then we have whole numbers. And then we have integers. And then we have rational.
Is it irrational?
And then they're not outside of rational because they're separate from rational. Irrational are on the other side. Okay, so let's let's look at this group of six and pick where they go. Okay, what is the square root of 64? Okay, 8. What is 8 times 2?
16.
16. So what type of number is that?
That would be a natural.
I agree it's a whole number. But what is the smallest group that it can fit into? Natural. It is a whole number. It is a whole number. But the smallest group that it can fit into is natural. Okay, negative 15 would fall under which group? Integer, because it's a negative. Okay. What is 16 divided by 4? 4, which falls into which group as the smallest group? Natural. The smallest group. We're looking for the smallest group.
Oh, yeah.
Square root of 75. Is that a perfect square?
No.
No. So it has to go in the irrational column. Okay, 0. Whole. It's the smallest group it can fit into. And negative 12.2. Is that an integer? Is it a whole number and its opposite?
Rational.
It's got to be rational because it's a decimal. And all decimals can, all terminating decimals can be written as a fraction.
Yes, sir.
Okay. Since this is a terminating decimal, it goes in the reals. So does anyone have a question about why those things are placed where they're placed?
No.
No? Okay. So let's list these here. List all of the number sets that each value can belong to. Circle the most specific set for each real number. Okay, 12 pi, 12 times pi. Is that going to be rational or irrational?
Irrational.
Why is it irrational?
Because pi.
Because pi. And is there any other group to put it in? No. So it's just I, just irrational. Square root of 30. Is that a perfect square?
No.
So I again. 45 divided by 5 is what value?
9.
9. Okay. So I'm just gonna write 9. Well, I'll try to write a better 9. 9. Okay. And then what is group that it could fall into?
Rational.
Okay, it could be rational. What else could it fall into?
Whole number.
Whole. What else can it fall into? Integer. And natural. Okay, now it said to circle the one that was the smallest thing that it could belong to. So what's the smallest set it could belong to?
Natural.
Natural numbers. Is everyone okay with that? Is that a okay idea?
Yeah.
Okay. Okay, what's the square root of 64?
8.
8, but it's what kind of 8?
Negative.
So I'm going to write the value down first, negative 8. And what would that fall into?
All of them.
Integer
Integers.
and
Rational.
rational. And real quick, because I and I look real similar, I'm just gonna put I in for nope, IR, sorry. IR for irrational. Okay. And lastly, 50.75. What do you think? 50.75.
Rational.
Rational. It's not an integer because of the decimal, right? Integers don't have decimals. Integers are just whole numbers and their opposite. Just whole numbers and their opposite. So no decimals. Okay? I want you to try 3, 4, 5, 6 real quick.
Good gracious.
3, 4, 5, 6.
I'll give you about a minute. We'll see. 2 minutes. 2 minutes. It's okay if you don't finish. Just do your best.
Wait, number 3 was kind of easy if you really think about it.
Well, then really think about it. Yep.
I'm confused.
Don't be confused.
Part 5.
Did you read the thing? Okay. Well, read the instructions. Read the instructions. Okay, another minute or so. Okay, Landon, you give me a guess for number 3? Okay, 15. 15, but is 15 irrational? So we have to think of a number that's irrational, that's 15. So let's do this, 15, and let's make a decimal that never ends. So 0.32 ... So that would be a way to do that. Garen, did you have one?
11.3, continuing or whatever.
Repeating decimals are not irrational. Repeating decimals can be written as a fraction. So, for example, 0.33333 is 1/3. So, you could change that to like 342 ... What about if we used a square root? We need a square root bigger than what number? So what number square rooted gives me 10? 100, right? So any number bigger than 100. So square root of 101, that would work. The square root of 1,872, that would work. Yes.
I used 4 times pi.
4 pi would also work because pi is 3.14-ish. So that would be 12-ish, right? Okay. Now, 4 says an integer between 5 and 6. Somebody want to volunteer their response? Mason.
Negative 5.7.
Can an integer have...
Integers don't have decimals.
Correct.
Oh.
So this one is not possible. I'll put NP, not possible. And that's because... I'm going to do B/C for because... Integers cannot have decimals. Another reasoning that you could use is you could say no, because integers are whole numbers and their opposites, and so there's no whole number between 5 and 6. Okay. What about number 5, Raphael? Okay.
So numbers can go down to 0.
Because whole numbers start at 0. So it can't be less than 0 because they start at 0. Okay. And lastly, rational. Anybody? Zuli, you got one? Okay, square root of 49. Because square root of 49 is what value? 7. So we have to pick a what? What do we have to pick for a rational number? A perfect square root. Okay, you have to pick a perfect square root. Anybody have a question about those 4?
No, sir.
Okay.